going to talk about the radius of anions and the trends in their radius, and I want to compare that to some of the things for cation that we've already talked about. First, I want to point out to you that for anions, as we go from left to right across the periodic table, looking at the most common oxidation state, the radius again gets smaller, not nearly as much as for cations, but still to a certain degree, and that again is because of the increasing effective nuclear charge. I do want to point out to you, however, that there are two things actually, the increasing effective nuclear charge, but if you look at O2 for instance, or O-2 and F-, they both have the same number of electrons, but fluorine has more protons. You've got the same number of electrons in O-2 and F-1. Fluorine has more protons pulling on the same number of electrons, so it pulls the electron cloud in a little bit more, making the radius a little bit smaller. And we've got the same trend we saw with cations going down the periodic table. As the N level of the valence shell gets larger, the radius gets larger. And that actually leads to our next point. What you'll notice is as we go from the neutral atom to the cation, the radius gets smaller. But when we go from the neutral atom to the anion, the radius gets larger. And that again has to do with the N level of the valence shell. For a cation, for lithium for instance, when we go from lithium neutral to lithium +1, the N shell, the outermost N shell for lithium is N equals 2. When we go to lithium +1, we've removed the only electron in lithium's N equals 2 shell. Now the outermost shell is actually N equals 1, and we have a smaller ion compared to the neutral atom. Same thing for beryllium or boron. When we remove 3 electrons from boron, we're removing all of the electrons from its N equals 2 shell, and the outermost shell is the N equals 1 shell. Smaller N number, closer to the nucleus. On the other hand, when we go for the anions from the neutral atom to the anion, we're adding electrons until we've filled the outermost shell. Since we're filling the outermost shell, in essence, we are adding more electrons to the atom. You have the same number of protons pulling on those electrons, and it can't pull them in as much. So oxygen neutral has 16 electrons being pulled by 16 protons. When we fill the N level, it now has 18 electrons being pulled on by the same 16 protons. Not as much positive pulling, or the same amount of positive pulling on more negative, and the cloud spreads out a little bit more. Same thing for fluorine. We've got 17 protons in fluorine, excuse me, I made a mistake. We've got 18 protons. We've got 8 protons in oxygen, pulling on 8 electrons, going to 10 electrons in oxygen, being pulled by 8 protons. I accidentally said the wrong number of protons. Oxygen has 8 protons. In fluorine, we have 9 protons. In the neutral atom, 9 protons pulling on 9 electrons. In the anion, we have 9 protons pulling on 10 electrons. Same number of protons pulling on more electrons. And they're not going to be able to pull the electron cloud in quite as tightly, and the cloud is going to be a little bit bigger. The radius is going to be a little bit larger. So oxygen 8 versus 8 for the neutral versus 8 versus 9 for the anion. Fluorine 9 versus 9 electrons and protons for the neutral versus 9 protons pulling on 10 electrons for the anion. The anion is a little bit bigger.